All right, in this section, we're going to be looking at quadratics. Now, it's been a while since you messed with the quadratics, and this one to tell you that quadratics are anything in the form ax squared plus bx plus c equals 0. Okay. Now, a couple ways you can solve quadratics. You can always graph them, but the bummer about graphing them is that you don't always know if you have all the solutions because sometimes you can get complex. The other ways you can do is factoring, square rooting. Those guys sometimes work. I'd say about 85, 90% of the time they work. But the ones that always work is completing the square, which you probably didn't do in advanced algebra 2, and the quadratic formula, which I'm sure you did in advanced algebra 2. So let's just go through and I'll show you a few things real quick. All right, so this first one, 4x squared plus 22x equals 12. Well, what I'm going to do first is I'm going to bring that 12 over. So I'm going to go 4x squared plus 22x minus 12 equals 0, right? But then I can see that they all have a common factor of 2, so I'm going to divide everything by 2. So now I have 2x squared plus 11x minus 6 equals 0. Okay? So for this, I'm going to try to factor it. So I'm going to do the x factor, a times c, which is negative 12, and b is positive 11. So what are my factors of negative 12 that add up to positive 11? That's right, it's 12 and negative 1. All right, so then I go ahead and do my little rectangle here, my magic rectangle. In the left corner, I put the 2x squared. In the lower right corner, I put the negative 6. And then here I'm going to put 12x and negative 1x. Going left to right here, what do they have in common? I believe that's an x. Going this way, they have a 6. Up and down is a 2x. And then here is just a negative 1. So now my factors of this are 2x minus 1 times x plus 6, and that equals 0. So if I do a little math, I now have x equals 1 half and x equals negative 6. Those are my two x-intercepts, also known as my zeros of that function. Okay, you could do it that way. Now, another way you could do it is if I actually divided everything by 2 again, and I did 2x squared plus 11x equals 6. Now what I want to do is I want to complete the square. So what I'm going to do is I'm going to take half of b. And if I take half of b, what's half of b? Half of b is 11 over 2. And I square it. If I square 11 over 2, I get 121 over 4. Now if I add 121 over 4 here, I have to add 121 over 4 there, if that makes sense. All right. Now, what I did here is now this should factor out nicely. Wait a minute. 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 Goof that up. Let's go back. Instead of dividing by 4, okay, for completing the square, instead of dividing by 4, what I want to do, or dividing by 2, I want to divide both sides by 4. So now I have x squared plus 22 over 4x equals 3. Okay. Now, I'm going to reduce 22 over 4 into x squared plus 11 over 2x equals 3. Now what I'm going to do is I'm going to take half of 11 over 2. Now taking half of this would be, all you do is double the denominator. So that's 11 fourths. I'm going to square 11 fourths, and that gives me 121 over 16. And so I'm going to add 121 over 16 here. Now this left side now becomes x plus half of b, 11 fourths squared. So if I squared the first, squared the last, and multiplied the two together and doubled, I get what's above. And then this with a little polishing, let's see, 16, what's 16 times 3? That's 48. So that's 48 over 16 plus 121 over 16. That's what's 121 plus 48? That's 169. So now you have x plus 11 over 4 squared equals 169 over 16, if that makes sense. Okay. Now with this, how do you undo something squared? You square root it. So this side is x plus 11 over 4 equals plus and minus 169. What's the square root of 169? Isn't that 13? Plus or minus 13 over 4. So if I subtract 11 over 4 here, I get x equals negative 11 over 4 plus 13 over 4 and negative 11 over 4 minus 13 over 4. And I know it looks a little complicated, but it works. So negative 11 plus 13, well, that's 2. So that's a half. That's the one we got over there on the left. And then this is negative 24 over 4, which is negative 6. So it works 100% of the time. Make sense? All right. I know it's a little shaky, but you haven't completed the square. When you do it a couple more times, it'll be all right. Now this one, there's a couple ways you can do it. Since this has no b or c, I could actually divide both sides by 4, right? And I get x squared equals 2. So then I take the square and x is equal to plus and minus radical 2. Fair enough? Pretty easy. I could have also brought it over and tried to factor it and all this stuff, but I just wanted to demonstrate those two ways. Again, not too tough. Now this one right here, I would do, if this were me, what I would do is I would divide both sides by 5, and I get x minus 3 squared equals 3. Okay, so what you can do is you could technically take the square root of both sides. So now you have x minus 3 equals plus and minus the square root of 3, and then you add 3, so x is equal to plus and minus radical 3 plus 3. Okay, that's the way I would have approached it. I wouldn't have done it any other way besides that, because it's just a big old x squared, really. Okay. This one right here, I have 8x squared minus 24x plus 3. I'm going to show you what I would do here. First off, I would try to get it so it is equal to 0, which it is. I could factor this. I'm going to try to x factor it. I'm going to say, all right, so a times c is positive 24 and b is negative 24. So what are your factors of 24 that add up to negative 24? And there is none. You don't have anything that are factors of negative 4 that add up negative 20 factors of 24 that add up to negative 24. So factoring will not work. All right, factoring will not work. What I could do is I could try to do the quadratic formula. The quadratic formula is always good to do. If you remember what that one was. Okay, but I'm going to do something sneaky, very sneaky. And I'm going to do what's called completing the square. So to complete the square, what you got to do is you got to get the squares and the x's on one side and get that negative 3 over here. All right, so I got that negative 3 right over there. All right, now what I want to do now is I actually want to divide everything by 8. So if I divide everything by 8, I get x squared minus 3x equals negative 3/8, if that makes sense. So now I want to take half of b. Half of b is negative 3 halves. And I square that, I'm going to get positive 9 over 4. If I add it here, I have to add it here. All right. So now this becomes x minus 3 halves squared equals, and then I'm going to change this to an 18 over 8. Right. So then this becomes 15 over 8. And that becomes a 15 over 8, right? So now what I'm going to do, okay, well, how do you get rid of something squared? You square root it. So x minus 3 halves equals plus and minus the square root of 15 over 8, right? And then what I'm going to do is add 3 halves to both sides. So x is equal to 3 over 2 plus and minus radical 15 over 8. Now I know that seems a little bit uncomfortable. There's a little more polishing up we can do, but that will work for now. All right, you could have easily dove right into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a if you wanted to, but the completing the square works. We're going to do the quadratic formula in just a minute. Okay, so here's one, 4x squared equals negative x minus 2. For that one, 4x squared equals negative x minus 2. What you could do is you actually should bring all that junk over. So now you got 4x squared plus x plus 2 equals 0. All right. Now I could try to factor this, but I go a times c is 8, and where are my factors? Well, we could try it. A times c is 8 and b is 1. Where are my factors of 8 that add up to 1? Can't think of anything. So what I'm going to do is I'm just going to go ahead and do the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, a is 4, b is 1, and c is 2. Okay, so plug this in. Negative 1 plus or minus the square root of 1 squared minus 4ac all over 2a, so all over 8. So now I get negative 1 plus or minus the square root of 1 minus 8 all over 8. So then this becomes negative 1 plus or minus the square root of negative 7 all over 8, which you should probably know that this becomes negative 1 plus or minus I radical 7 all over 8. So that's a complex answer, which means that if you were to do it to graph it, you wouldn't see it have absolutely no intersection. And then maybe in advanced algebra 2 you talked about the discriminant b squared minus 4ac. If you remember b squared minus 4ac, that's the chunk of the quadratic formula. Well, in this case, this one produced a negative answer that gives you 2 complex. If you get b squared minus 4ac is greater than 0, you get 2 real answers. And if you get b squared minus 4ac equals 0, you get 1 real answer. Now, I don't know if you did that in advanced algebra 2, but maybe you did. On this one right here, this one looks like you can't do anything, but if you look at it closely, it's 3x to the 4th minus 5x squared plus 2. The crazy thing about it is it's kind of like this. Let me write it like this. It's kind of like 3 times x squared minus 5 times x squared plus 2 equals 0. So it's kind of like a perfect, it's kind of like a quadratic. Okay, it's kind of like a quadratic. So really, if I do this, I'm going to replace the x squared with the letter u. Now I have 3u squared minus 5u plus 2 equals 0. Now let's try to factor this cowboy. So I got a times c, that's 6, and that's negative 5. What are your factors of 6 to add up to negative 5? That's negative 6 and positive 1, right? So you draw your box. Right here you put the 3u squared. Down here you put the 2. You got negative 6u, and you got positive 1u. Going this way, you factor out a u. Going this way, you factor out a negative 2. Up and down is a 3u, and then this is just a 1. So now you have 3u plus 1 times u minus 2 equals 0. So you have u equals 1/3 and u equals 2. But what's u? U is x squared. U is x squared. So when you replace that, now you have x squared equals 1/3, and you have x squared equals 2. So x is equal to plus and minus the square root of 1/3, and x is equal to plus and minus the square root of 2. Okay? Okay, so hopefully that makes sense, and I'll see you all in class. May the force be with you.